In the last video, we have finished the FEOL simulation. However, I wanted to revisit this file once again because I have introduced this feature. So as you can see, now we have gate cut. So in my former example, I forgot to introduce gate cut, and of course this is corresponding to an inverter, and we have other different uh, logic gates here and there. They should be isolated. So in order to make this isolation, we introduce a gate cut, and this cutted gate part is filled with a plug insulator, so not shown here. And right now, when we have a look at the side view of this system, so here you can see this is corresponding to the uh, gate. Yes, this highlighted part is corresponding to the gate, and this is corresponding to source and drain. So now you understand the height of this gate and height of source and drain are the same, but as much as I understand, they are not in the same height. So I have to find out how can we introduce such a more realistic procedure. And as you can see here, we have green lines corresponding to fins, and yes, also um, if we just eliminate um, this uh, line of material and tungsten, then we can see here source and drain. So they are made by epitaxial growth. So of course, in the case of a realistic procedure, we have different shape, different material for N MOSFET and P MOSFET. However, we have the same one in this simple emulation. Mm, this is corresponding to the spacer. This is a spacer, and in my opinion, uh, currently my numbers for each layer height uh, is not that accurate, so that's the reason why I'm not certain that my structure has a proper dimension, especially along the G direction. So I have to dig out a little bit more, and yes, so this part is corresponding to, I guess, that interlayer dielectric 0, and mm, well, now we are approaching to the more realistic or more important part, the intrinsic part. So now we have a source and drain epi, and mm, yes, and also we have a oh, no, no, not this one. Yes, this is corresponding to the K, to the spacer, and now we have a gate. Well, how tall is it? Well, I'm not that sure about that. Right now, the height in my calculation is about 140 from this STI top to the very top of this entire structure, but uh, I think that it is a little bit short, but when we just have a look at certain schematic diagrams for these structures, usually we have a comparable dimensions for fin and other parts. I'm not sure whether that is exaggerated or not. So that's the reason why I have to spend more time to find out it more realistic values. But anyway, so I'm going to stop here for this fail simulation, and eventually I will move to the next part, the back end of the line simulation and other one. So currently we are working with uh, this inverter example. These are 3-pin P MOSFET, and these are 3-pin N MOSFET, and also their gates are connected. Um, However, how can we make this signal out? So that will be done in my next videos. Thank you and see you later.